This is the Algebra 1 Summer School Unit 6 Lesson 1 Notes video. We're going to be solving by factoring today. This unit is all about solving quadratic functions. We just finished the factoring unit, so you should be really good at factoring all different kinds of polynomials now. We're going to start this unit with how do I solve a quadratic when I'm factoring? Well, when I solve anything, solving means to find the value of x that make the equation true. So we're going to be finding the values of x that make the equations true here for these quadratic functions. What we use when we solve by factoring is something called the zero product law. The zero product law basically says that if you have two things multiplied together and one of them equals 0, and their product, when they multiply together, the answer is 0, then one of those two numbers has to be 0. Okay? Let's use the zero product law to find all solutions to the following equations. Number 1 and 2 start out just very simply for you. They're already polynomials in factored form. Remember we would do split the middle or difference of squares or GCF in order to get this setup where we had two binomials multiplied by each other. This example starts with the two binomials, and we're just going to show you how the zero product law works. Once you've factored a quadratic and it looks like number 1, what you do is you take the first factor and you set it equal to 0. Notice that the zero product law has the whole equation set equal to 0. We want to figure out what are the answers when the equation is set equal to 0. So I take that first factor, I set it equal to 0, and I solve for x. When I do that, I get x equals -7. That is one of these solutions to the quadratic. Then I take the other factor, x minus 2. I set it equal to 0 and solve for x. When I do that, I find that my other solution is x equals 2. Let's look at number 2. Very similar. I have two binomials, 2x minus 1 times 3x plus 4. I'm going to take the first binomial, 2x minus 1, and set it equal to 0. To solve that, I add 1 to start. Then I have 2x equals 1, and then I divide by 2. One solution that I get is 1/2. That is one number that would make this equation equal to 0 if I were to stick that in for x. The last root I'm going to check is 3x plus 4. All right, I'm going to solve this the same way. I'm going to subtract 4 from both sides. And I get 3x equals -4. And then I'm going to divide by 3. That gives me a solution of x equals -4 over 3. So sometimes our solutions are whole numbers, as in number 1, or fractions, like in number 2. Either are okay. So that's how the zero product law works. Let's go back and actually solve a quadratic by factoring and then using the zero product law. So let's jump back to remember how we would factor quadratic expressions. Remember that when you factor, you always want to look for a GCF first. That's the first thing you have to do when you are trying to factor something. So when I look at x squared plus 4x minus 12, there's no GCF between them because none of the terms have one number that you can pull out or an x. So I start by remembering that there's a 1 in front of the x squared, and I multiply that first term by the last term. 1 times -12 is -12. So my goal is to find two numbers that multiply to -12 and add to that middle number of 4. Well, the two numbers that multiply to -12 and add to 4 are going to be +6 and -2. Once I've identified those numbers, I can go ahead and split the middle. Remember, when you split the middle, you bring the first term down, the x squared, and you bring the last term of -12 down as well. Then I split the middle term of 4x into +6x minus 2x. Every time you split the middle, you're going to end up with a line of work that has 4 terms in it. From that line of 4 terms, we use the method of grouping, which means you take the first 2 terms and the last 2 terms and put them in groups together. From those groups, you're going to look for a GCF. So the GCF between x squared and 6x is just x. I divide the x out of both terms, and I end up with x plus 6. Now when I look at the second set of terms, because this negative 2 is negative, my GCF is going to be negative, and the GCF looks to be negative 2. So I'm going to take a negative 2 out of each term, and I'm left with x plus 6. Remember that a negative 12 divided by a negative 2 is positive 6. Well, the good thing about this is that we have x plus 6 in both parentheses, so that then you can take the terms in front and write them as a binomial x minus 2 times x plus 6. Now we factored, but what we need to do is use the zero product law in order to find the solutions of this quadratic. So I'm going to take each of these factors, x minus 2 and x plus 6, and set them both equal to 0. That allows me to find the solutions for this quadratic. Well, for this left-hand one, all I have to do is add 2 to both sides, and I get x equals positive 2 is one of the solutions. On the right-hand factor, I subtract 6 from both sides and get x equals negative 6 as one of the solutions. Right? So that's solving by factoring. Now let's go back up to the next problem, and let's see if we can do number 4. Number 4 is 2x squared minus 14x. Remember what we said at the beginning of this lesson, that we always factor by looking for a GCF first. So you should be able to notice that 2x squared and negative 14x have a GCF. 2 and negative 14 have a 2 in common, but both terms also have x's in common. The first one has 2 x's, the second term has 1. So I can pull 1 x out of both. So my GCF is 2x. I'm going to divide both terms by 2x and figure out what's remaining. 2x squared divided by 2x is just a plain old x. And negative 14x divided by 2x is minus 7. That's it. That's the fully factored form. So once I've factored, I set everything equal to 0, so I can use the zero product law to find the solutions. I'm going to take the first factor, 2x, set it equal to 0, and take the second factor of x minus 7 and set that equal to 0. In order to solve the factor on the right, I have 2 times x. So I divide both sides by 2, and I get x equals 0 divided by anything is 0. So 0 is one of the solutions that make that quadratic true. To solve the second factor, I just add 7 to both sides, and I get x equals 7 as one of the factors that make this true, or one of the solutions, I'm sorry. All right, a couple more problems here. Let's move on to number 5. Number 5, I have x squared minus 25. Well, there's 2 terms, so I can't use split the middle. There's not a GCF, but what I can do when there's 2 terms and a minus sign is I can see if I can take the square root of both terms and use the difference of squares. So let's see. I can take the square root of x squared. That gives me x. I can take the square root of 25. That square root is 5. So because I can take the square root of both terms, there's 2 terms, and there's subtraction, I'm going to use my factoring method of difference of squares. So here I put the x in both parentheses, the 5 in both parentheses, and a plus and a minus in each. Now that it's factored, I'm going to use the zero product law to find the solutions. So I'm going to take x plus 5, set that term equal to 0, and take x minus 5, set equal to 0. That helps me find the solutions to the quadratic. I'm going to subtract 5 to start on the left-hand factor, and get a solution of x equals negative 5. And then on this right term, I'm going to add 5 and get x equals positive 5. Those are my two solutions to that original quadratic, negative 5 and 5. All right, for number 6, 2x squared plus 5x minus 12. There are 3 terms in this polynomial. There's no GCF, so I'm going to go ahead and use split the middle. This time when I use split the middle, I'm going to multiply the 2 and the negative 12 to get negative 24. I need to find 2 numbers that are going to multiply to negative 24 and add to the middle number of 5. Those numbers are 8 and negative 3. From here, because I found those 2 terms, I'm going to split up this middle term of 5x. So I bring down the first term, 2x squared. I bring down the last term of negative 12, and I'm going to split up the 5x into plus 8x minus 3x. That's the same polynomial, it just looks a little different. Now that I have my 4 terms, I go ahead and group the first 2 together and group the last 2 together. Now I go ahead and look for my GCFs. The GCF between 2x squared and 8x is 2x. When I take 2x out of both terms, I'm left with x plus 4. When I look at the second factor, this factor, the negative 3, has a negative in front, so my GCF is going to be negative, and there's a 3 that goes into both of those terms. So my GCF is negative 3, which I go ahead and divide out of each term. Negative 3x divided by negative 3 is x. Negative 12 divided by negative 3 is positive 4. As always, the good thing there is that the x plus 4s are exactly the same. So then I can write my factored form of 2x minus 3 and x plus 4. Now that it's factored, I set the whole equation equal to 0 and then use the zero product law to find each root. The zero product law says I take each factor and set it equal to 0. When I solve for x, that's going to give me the solutions to the quadratic. So I'm going to add 3 for this left one. I get 2x equals 3, divide by 2, and I get x equals 3 over 2. On this last one, I subtract 4, and I get x equals negative 4 as the other solution to the quadratic. Quadratics always have 2 solutions. All right, we have one more problem to do here. This is an OST question. It says an equation is shown, 2x squared minus 5x minus 3. What values of x make the equation true? Well, this is a problem where you would have to use this zero product law to find the values of x that make the equation true. That's another way of saying what are the solutions to this quadratic. So what I would do is I would rewrite the 2x squared minus 5x minus 3. And you're going to use split the middle to factor this. So I'm going to multiply the 2 and the negative 3. That gives me negative 6. I need 2 numbers that multiply to negative 6 and add to negative 5. Those 2 numbers are going to be negative 6 and positive 1. So I split the middle here by writing 2x squared minus 6x plus 1x minus 3. I can now go ahead and group this polynomial and look for GCFs. The GCF between 2x squared and negative 6x is 2x. When I divide each term by 2x, I'm left with x minus 3. And then over here, the third term is positive, so my GCF is going to be positive. And the only thing that the 1x minus 3 has in common is a 1. So if I divide everything by 1, I'm still left with x minus 3. As always, I'm going to highlight that the x minus 3 and x minus 3 is really important. That allows me to write my fully factored form as 2x plus 1 times x minus 3. That factored form I now set equal to 0, and I can find the solutions to each equation. So I'll take 2x plus 1 equals 0, and x minus 3 equals 0. On the left here, I subtract 1 to start, and I'm left with 2x equals negative 1, and then I can divide by 2. So one solution is x equals negative 1/2. That's one of the numbers that goes into these blanks here. That's one solution. The other solution, I add 3 to both sides and get x equals positive 3. That's my second solution that makes the equation true. All right, that's your notes for solving by factoring. It's a fairly simple process as long as you know how to factor. There's 2 sets of practices for solve by factoring with answer keys and videos both posted on Canvas.